Alright, AP Stats, today we're going to look at different ways we have used the normal distribution so far. This is all review, however, we're going to combine it all so that we can distinguish when to use which process. So in Chapter 2 we talked about an individual or a single event occurring, and we used the normal distribution to find the probability of that. In Chapter 6 we combined random variables. So in Chapter 6 we were putting 3, 4, 5, 6 multiple random variables together and then calculating a probability based on that. In Chapter 7, we were looking at the average or the mean of multiple samples. So let's look at how I got these formulas for the mean and standard deviation in Chapter 6. In Chapter 6, we said, well, what if we combine a random variable multiple times? So let's say we combine 3 of them together. To find our means, we would say that's the mean of x plus the mean of x plus the mean of x, which gives us 3 times the mean of x. And then when we talked about standard deviation, we had to, of course, work in variance. So we would take the variance of x plus the variance of x plus the variance of x, which would give us 3 times the variance of x. But when we're working with the normal distribution, and in particular normal CDF and inverse normal, we need to be working in standard deviation. So what we would do is square root this variance of the combined random variables, and we end up with the square root of 3 times the standard deviation of all those x's combined. So that's where this came from right there. And then in Chapter 7, we said that the mean of a sampling distribution of sample means, the average of that is going to be the same as the population mean, and the standard deviation is going to be sigma over square root of n, the population standard deviation divided by the square root of n. So let's apply this combined information to this problem here. A bottling company uses a filling machine to fill plastic bottles with cola. The bottles are supposed to contain 12 ounces. In fact, the contents vary according to a normal distribution with a mean of 11.8 and a standard deviation of 0.98 ounce. So what we want to do is write that out so we can visually see that. We know that x is normally distributed with a mean of 11.8 and a standard deviation of 0.98. And what is x? X is the number of ounces in a bottle of cola. So part A says, what is the probability that an individual bottle contains less than 11 ounces? So what is the probability that one single bottle, so we are talking about Chapter 2, we are talking about an individual bottle. So we are looking for the probability that a single x is less than 11 ounces. So to do that, we're going to use the normal distribution, and we're going to use normal CDF in our calculator. And we want less than 11, which means our lower bound is negative infinity, our upper bound is 11, our mean is 11.8, and our standard deviation is 0.98. So we go ahead and enter that into our calculator. And depending on the type of calculator you have, yours may look like mine, so you put in your lower bound of negative infinity, upper bound of 11, mean of 11.8, standard deviation of 9.8, or maybe yours looks like this and you enter them in by commas. So when we press enter, we get 0.207. So that gives us about a 20% chance that a single bottle is less than 11 ounces. So that was part A. Part B, we are looking for the probability that a 6-pack contains less than 66 ounces. So here, this is Chapter 6. How do we know that? Because we're looking at a total of 6. We are looking at the total of all of them. And one clue to that is how this number here is given. 66 ounces is clearly a total and not an individual bottle. So to do that, we need to find, if we add 6 bottles together, 6 random variables together, what will be our mean and our standard deviation? Well, our mean is going to be 11.8 plus 11.8 plus 11.8 6 times. So if we type in our calculator 11.8 times 6, we get 70.8. That's on average. A total of 6 bottles will have 70.8 ounces. So what's the standard deviation? Well, the standard deviation is all the variances added together, and then we square root that. So we're going to add 0.98 squared 6 times, and that's going to give us our new variance, and then to get that we are going to have to square root. And so very simply, this is the square root of 6 times 0.98, which is about 2.4. So now for a total of 6 bottles, we have an average of 70.8 with a standard deviation of 2.4. So we want the probability that a 6-pack contains less than 66 ounces. And so we are going to find the probability that 6 X's added together, 6 individual bottles added together, is less than 66 ounces. So again, we're going to normal CDF. Our lower bound is negative infinity. Our upper bound is 66. Our mean is 70.8, and our standard deviation is 2.4. We type that into our calculators. And your calculator should look like this, or separated by commas, and we get 0.02275, so 0.0228. So there's a 2% chance that a 6-pack will have a total of less than 66 ounces. So that's chapter 6, that's part B. Then we have part C, which is the probability that the mean, the average content of the bottles in a 6-pack is less than 11 ounces. So look at the difference between question A and question B. Question A is an individual bottle. Question C is the average of 6. So this is from chapter 7. And so what we're looking for here is the sampling distribution. And we want to know the mean and standard deviation of that. So since we just learned that the mean of the sampling distribution is the same as the population mean, that's going to be 11.8. The standard deviation is smaller, so that's going to be 0.98 over the square root of n, which in this case is 6. And if we type that into our calculator, you can see we get 0.4. So we're going to have X bar, our sampling distribution, our averages, is normally distributed with a mean of 11.8 and a standard deviation of 0.4. So now we're looking for the probability that an average, so an X bar, an average of 6 bottles, is less than 11 ounces. So we are going to, again, normal CDF, negative infinity to 11 with a mean of 11.8, but this time we have a standard deviation of 0.4. We type that into our calculators. and we get 0.0228. So in Part A, the big distinction is between Part A and C. In Part A, we were looking at an individual bottle being less than 11 ounces, and that is 20%. But what is the probability that an average of 6 bottles is less than 11 ounces is going to be much smaller, because some are going to be more, some are going to be less, so it's going to average out a little bit closer to 11. So the probability that we're less than 11 is now only 2%. So what we have there is the difference between Chapters 2, Chapter 6, and Chapter 7, and the different times that we've used normal distribution so far. Have a great day.